to be with us here at this last session of the afternoon. Everyone having a good event so far? You're learning some stuff? Yeah? Excellent, excellent. And that does me a lot of good. Deep down inside where it really counts, I was one of the founders of PASS way back in the day and was president for 2 terms back in about 100 years ago, about 2004 to 2008. My name is Kevin Kline, and you can follow me on Twitter at KE-Kline. I'm on LinkedIn at KE-Kline, and I'm on Facebook. So if you put any of those in, facebook.com/KE-Kline, that's where you'll find me. This is my good friend, longtime colleague, Bertrand.
Hello, everybody. How many first-timers we have?
Wow.
Nice.
Thanks for coming.
Nice. How many were in my bad habits talk yesterday? Just a few. Okay. Don't worry. There's no overlap here. I think there's one slide that's quite similar. Everything else is different. Everybody having a good show? Everybody enjoying it? All right. First-timers, how many are going to come back next year? All right. It's good to see. Good to see. Well, not back. I guess you'll be going to Seattle. All right, so...
yeah, and you can find Aaron on Twitter as well, at Aaron Bertrand. So he actually likes to have his whole name in there.
Yeah, a lot of people use these SQL Squirrel and SQL Ferret and all these weird names. I just like my name.
Yep.
It's easy.
And it works. Yep. If you ever decide you want to change, maybe be something else, the NoSQL person. Right?
Yeah, maybe.
You don't have to change anything.
I don't have to change.
All right, so obligatory slide, number 1. Please silence your cell phones. If you choose to take a call, we'll enjoy hearing it everywhere because we'll insist on you putting it on speakerphone. So if it's not, take yourself out for your call. Just to make sure you're aware of it, you probably heard this dozens of times already, but this is the event, but it's not the only thing about this organization and association. There's year-round things you can do. There's the virtual chapters every month. There's different sessions you can attend online. As some are joining us right now for the past TV recording of this session, there are your local chapters. And also many other ways you can get involved and participate. There's all the things you can download after the fact, the streaming media. You can purchase the thumb drive with all of the slides and actual live video presentations on those recorded on. And they're really high quality too. So if you have the funds or your work will sponsor that, I encourage you to consider doing that. So a lot of ways to stay connected and stay involved, and I hope you'll take advantage of that. Also, now Aaron and I are long-time speakers. We've been doing this for a long time, but we still love to get feedback. We still love to hear about what you learned. We love to hear anecdotes, stories, examples. Sometimes people will take the time to tell us, something you taught me made my life better. And that's a great experience. That really makes it worthwhile for us. Love to hear that kind of stuff. Some of you also fill out evaluations to say, I just wasted an hour of my life. So yeah, we understand, if you have constructive criticism, we'd love to get that too. But I'm just teasing. Hopefully nobody will be disappointed. We've got a lot of good information for you in here as we go along. All right, so what are we going to talk about? Let's move on. The agenda. We've already introduced ourselves, so we don't have to go into that too terribly much. We're going to spend a little time talking about setting up a stable and predictable environment for your SQL code. Right? This is extremely important. We're going to go from that into some of the basic ways to assess what your SQL is telling you and some of the things that might be causing problems. We're not going to go into that in a very, very deep way, but we're going to give you the quick kind of one-slide overview of that. Then we've got the meat of this presentation. So we've got at least 10 different things we're going to tell you about. And then finally, we'll wrap up at the end. We should have time for questions throughout, but we might have time for questions at the end as well. Sure. Okay. Now, there is a microphone right here, but just kind of in keeping with what most of the other speakers have done, if you want to just raise your hand from your seat, we'll recognize you and take your question from the floor. You don't have to go to the microphone. All right? So let's talk about setting up a stable, predictable environment. When I first started working with SQL Server, it was actually before there was a Windows operating system. And so one of the things that was kind of an interesting and a new learning experience for me working with writing SQL statements was that I'm writing code, and I turn it in and it gets reviewed by my mentor at the time. And it's not performing right. And he says, go back and rewrite this and make it run within this certain amount of time. And so I tried it again, and I rewrote the SQL statements, and it was really fast. It was a lot faster than what had happened before. And I was like, I'm a T-SQL god. I'm so good. I rewrote it. It was slow, and now it's fast. And I took it back to him, and he said, oh, that's really smart, Kevin. What did you do about the caching with your query? And I said, what is this caching you speak of? What are you talking about? And what I didn't realize was that I had written a query that pulled out a lot of data, loaded it into the cache, retrieved the result set to me. And then I went back and wrote a new query, which took a little bit of time to compile a new plan, but all the data that I was accessing was the exact same data. It was already in cache the second time I ran it. So even though I rewrote it, it wasn't actually a faster query because the query wasn't any better. The data was already in cache, and so that's what I had experienced, was I had everything up in the cache that I needed on the second run, but not on the first run. So one of the things I learned at that time, now at that time, in the very early days of SQL Server, the only way you could clear the cache was to actually restart SQL Server. It's kind of inconvenient when you've got a lot of people on the SQL Server, right? Well, times have changed, and so we can clear out the cache manually, actually, issuing a few commands. So one of the things I like to do to make sure I don't make the mistake that Kevin in the early 1990s made is first I like to issue the checkpoint statement. Checkpoint will do a number of different things, but the main thing it does is to clear the dirty pages out of the buffer cache and move them out to the I/O subsystem. The next thing you can do is to clear out each of the two main areas of the SQL Server memory reservation. So you can clear the procedure cache and flush all of the plans that are stored in the cache. And then you can also clear out the data buffers, or the data cache. And so you would use two DBCC statements. Typically what I use, since I work from my laptop, I have a workstation that's just for me. So typically I clear out the whole plan cache at one time. So I'll issue the command dbcc free proc cache, which clears the entire procedure cache. You might be in an environment with a big dev server, and so there's lots of different developers working on that. And you don't necessarily want to do that because it will clear everybody's plan out of the cache. So you could use the free, as dbcc free proc ndb, and you give it the database ID number, and then that will clear out the procedure cache just for that one specific set of stored procedures related to that database. So any select statements, any stored procedures, any of those kind of plans, they're loaded into the plan cache just for that one.
You can also free the plan for a specific plan. So if you have the plan handle, you can pass that in as an argument as well.
And there's a really good blog about that. I believe Glenn Berry wrote about a blog post about that. So if you want to clear out just one specific plan, you can actually drop that one out of the cache too. That would have made my life a lot easier way back in the day. So that's one way to do it. You can also clear out the buffer. And that's pretty much all or nothing. So you would need to do a dbcc drop clean buffers, and that clears out the entire buffer cache. Don't do this in production, please. Please don't do that in production. People will come looking for you. It's like, oh, everything is slow, right? So a couple more things you want to do is you want to set up your environment in such a way that you can take measurements, right? We have to know how things performed before, or we have to take the measurements of what was before and what was after to see what the delta is, to see what the difference is. Now, I've got a couple different commands here that you can use. You can also just graphically go into SQL Server Management Studio and check boxes to turn on or off these different features. The ones I like to use a lot, I like to use set statistic time, and you say set statistic time on, set statistics IO on. Each of those gives you different information about the behavior of the SQL statement that you're testing. Time will tell you the elapsed time and the CPU time that was consumed to process that particular query. You might see a situation in which the elapsed time is greater than the actual clock time that passed, and that's because you've got multiple CPUs spinning on this query, and they're accumulating more CPU time than the clock time that's gone by. So maybe it says 4 minutes when only 1 minute has passed. It's because it's got 4 minutes, 4 CPUs processing on this. The I/O measurement is one I find that is not used very often. I'd like to see people use it more. It tells you some very, very valuable things about how many scans are happening, read-aheads, logical reads, which come from memory, physical reads, which has to be buffered from the I/O subsystem first and then into memory, so those are going to be a lot more costly. So those will really help you figure out how expensive it is to run one of your SQL statements. The show plan text is just the way I like to do it because I'm so old school. I started, way back when, character mode, and we had punch card. No, I'm kidding. We didn't have those in SQL Server. That was earlier stuff. So you can use this if you want to see the text returned to you right there, but most people use the graphic execution plans. Okay? So that's what we're going to show you today as well. We're not going to actually show you the textual plans. There's also some DMVs that you want to look at consistently as you go along at different touch points along the process of tuning your queries or writing those out in the very first place. There's a couple of them that have existed in various stages and various versions over the years. So if you're still using SQL Server 2000, you would get wait stats and things like that through a DBCC command. But now you can get your wait stats, for example, from DMOS wait stats, right? And with an underscore between each of those. You can get perfmon counters for SQL Server using DM_OS performance counters. And so this might be useful for you to pull out, like, for example, if you're tuning an insert statement, how many page splits am I getting on this operation? So that's the kind of thing you can find out with a perfmon counter that's in the performance counter DMV. The last couple DMVs that we mentioned in that list, those are referential. We're not going to really go into those in too much detail here, but those are useful DMVs to use. And you might want to take a moment and look up some of the other sessions that are being presented here, and you can see those as they're streamed later on, such as Tim Ford's, he has one on the DMV table of elements, I guess you could say. And so
I think periodic table.
Periodic table, thank you, yes.
So that's like it looks like the chemical or periodic table, and it has all the different DMVs listed there, categorized.
Exactly, yeah. So if you want really in-depth information on those DMVs, you can look that up after the fact. And you'll see a lot of this stuff in action as we go along. All right, yes, question? Is there an easy way to reset the wait stats? And the answer to that is yes, there is actually. There is a DBCC statement you can use. And unfortunately, I don't remember the exact syntax for it. I believe it's SQL, is it SQL perf?
I think DBCC SQL perf wait stats.
Wait stats, and then
Clear.
Wait
stats.
Thank you.
That's right.
Clear.
That's right.
Thanks, Jim. So we're looking at queries. We're doing all kinds of work. What's bad, right? What means we need to investigate more for troubleshooting? What means we even need to troubleshoot? Well, of course, the correct answer to any technology question actually is, it depends. Thank you. Right. But in general, here's what I look for. Not knowing anything else about the query or the database design or different things like that, I'm going to look for scans. I'm going to look for table scans. If I don't know a lot about the data and it's just a 64K table, 8K pages, table scan might not be very costly at all. But I have to assume that it's going to be a lot of data. So if I see table scan, I'm going to be a little bit alarmed. How about if I see clustered index scan? It's got that word index in there. That sounds pretty good, doesn't it? What's a clustered index, though? It's pretty much the whole table, isn't it, right? That's a physical sort order of the table. So, yeah, even if it says clustered index, it could be costly, right? There are some sorts of scans that aren't always bad, like a range scan. That could be good. It bounds the particular search of records to a certain range. But if I see a scan, I'm going to investigate it and make sure it's not a terrible thing or a bad thing. There's another set of operators you'll see, lookup operators. So if you're on SQL 2005, you might see bookmark lookups. In later versions, you'll see key lookups and RID lookups. Those usually indicate that we could benefit in some way from a new index or an added index or something like that. Some of the other ones we look for are spools. Spooling operations usually mean something is getting buffered out to TempDB. We're spilling that out, so there's a lot of I/O going to happen for that particular operation. And then parallelism. Now, parallelism is not bad in and of itself. And there are some kind of myths floating around that, oh, you know, you've got max degrees of parallelism as your highest weight stat, so you need to turn it off.
CX packet. A lot of people freak out about CX packet weight. That's not the problem. There's something else causing that problem.
Something else causing
That's a victim.
Yeah, that's sort of the symptom of some other illness underneath. But I do like to take a look at parallelism and see if that's in play at all and it's working appropriately. Because sometimes parallelism is going to be your best friend and it's going to speed this query up enormously. Only sometimes, though, not every single time. Now, those are inside the execution plan. All of those different things you'll see, perhaps with a different prefix or suffix on it. You know, the lookups, for example, could have several different values in front of it, key lookup, RID lookup, execution plans. But there is so much good information outside of execution plans. The first thing that I always look for when I'm looking outside of the execution plan is I look at both the estimated execution plan and the actual execution plan. And if the numbers that it shows are dramatically different, I know instantly that SQL Server has very bad statistical information that's probably stale. Indexes have not been updated in a long time. So you'll see lots of queries that return the information to you and it says estimated number of rows, 37,000. Actual number of rows, 12. Okay, something is wrong, right?
What that usually means is SQL Server is going to build a plan based on what it estimated would be there, which isn't necessarily the most efficient plan for what is actually there.
Absolutely. Physical reads, that's something to be concerned about a lot of the time. We'll find out why it's not being stored in the buffer.
It's usually a lack of memory.
Usually a lack of memory.
You can throw memory at that problem.
Right, we can't necessarily fix it, but sometimes that is something we can fix. Another thing that's pretty alarming when you see it is when SQL Server tells you, hey, I don't have an index for this particular table that if I had, I could use for this query. I don't have statistics for this particular query that I could use. So it will give you alarms in the later versions. I think 2008 R2, is it that when we started to get?
No, I think 2008. I think it was earlier, 2008, yeah.
So the statistics alarms came in a later release.
Yeah. Another thing you might see that's kind of related to that is when SQL Server doesn't have stats for something, it'll go and create those for you. So what it'll do is slow down your query, because now before you can resolve the query, you have to wait for the stats to finish. That's not usually a good thing either, especially if you're testing, because it can throw off what your timings and everything
Yeah,
else.
exactly. You got the stopwatch, and it's like, wow, it takes way a lot longer. Yes, question? Can those statistics be removed that are auto-generated? Actually, they can be. It's a little bit elaborate process, and you have to look at this, the system DMVs, because SQL Server has its own naming convention for these. But I wouldn't do it, personally.
Yeah, I mean, do you have a reason why you would want to remove those? I see. So you're not sure if you need them or not, and you want to drop them. So I don't think there's really a problem with dropping them. Just realize that if you do drop them and SQL Server runs a query that would use those again, it's going to recreate them,
Yep.
right? Unless you turn off auto-update or auto-create statistics.
Auto-create statistics, right. Now, another thing that's interesting, we mentioned sort operations in terms of spools, but there's certain kinds of things inside a SQL Server that will always cause a sort. And for example, hash joins, certain kinds of merge joins. And whenever SQL Server has to do large sort operations, that means it's going to do a bunch of work in TempDB. And we don't always tune TempDB for I/O performance the way we should. So that's something to be aware of and to look for. And finally, there's implicit data conversion as well. And we're going to talk about a couple of these sorts and so forth and data conversions in just a few minutes. Yes?
There can be other issues. So there's a.
Just repeat the question.
Oh, I'm sorry. Yes, I'll repeat the question. So the question is, when there are differences between estimated and actual rows, is it always a statistics problem, a missing statistics or stale statistics? And no, it's not. There are definitely different ways that SQL Server can interpret cardinality, and there are some bugs in SQL Server. Actually, Paul White and I were talking about a bug last week where in one of the date diff calculations, if you say where a date column is equal to date diff something something, it swaps those two parameters. So instead of looking for, if you say get date as part of your get date or as part of your date diff expression, it will evaluate that as 1786 or whatever, the difference between the number of months. It subtracts the number of months from today instead of add them. So it goes back to 1786 and it actually swaps the estimate and actual rows if you query for those dates. So there are definitely some other ways where statistics can be, or estimates can be off, and it's not because the stats are old.
But the short answer is it usually is the reason. Not always, certainly, but it is frequently the situation. So let me tell you a little story before Aaron jumps into cursors, right? And I'll take your question in just a moment. When I was working back in the old days in a big corporate IT environment, we had a large application that was being designed and written by some Oracle people. And the lead DBA on that project came into my office after a code review, and he had this big stack of papers, which were printouts of the different stored procedures. And he's like, take a look at this. And I take a look at it, and it says, stored procedure name, declare cursor, select from the cursor, fetch, and all this stuff. And, just everything went through a cursor. I was like, okay, that's cool. And I looked at the next one, and it's like declare cursor, do all this work, fetch, and next one, I went through, like, Dwayne, how many of these are there? And he's 400 plus. I was like, do any of them not use cursors? And he's like, no, actually, everything is done through cursors. I was like, wow, it kind of blew my mind. And as it turns out, if you have any background in Oracle, you might know that even in Oracle documentation, even a select statement is referred to as an implicit cursor. It's materialized in the exact same way, one to the other. A select statement is no different from a cursor, cursor is no different from a select statement. But in SQL Server, that ain't the case. What's the very last statement that we have in regards to a cursor when we're executing a cursor? What's the last thing you do with it? Deallocate it. You give back the resources that it consumed in a special way that was set aside only for it. You give back locks, you give back address and memory. Oracle doesn't do it that way. So when Oracle people convert to working on SQL Server, this is a really frequent mistake we see, overusing cursors all over the place. So I wanted to it's funny though, just to put the punchline on the story, we made him go back and rewrite it, and so the next weekend, Dwayne came into my office, this huge stack of papers, like, take a look at this. And I looked at the first one and it said, while this condition is the case, and I looped through this, go! So anyway, there is a better way to do that kind of functionality, and so Aaron's going to tell us about that.
All right, so we did have a question though, didn't we?
Oh yes, I'm sorry.
Yes. Could wrong estimates be caused by parameter sniffing? Absolutely. Yeah. So, and another thing that can cause it, and we'll talk about this later on, is UDFs. So if you have a scalar UDF, if you have a table variable, there are a bunch of different structures in SQL Server that just don't have exposure to the optimizer. So the optimizer has to make assumptions about what's in there. So you could put 10 rows into a table variable or 1,000 rows into a table variable, and SQL Server is going to assume that's the same thing, and it's going to assume one row is coming out of there or whatever.
Every single time. Yep. All right.
Yes.
Are there ever times when the cursor is a preferred approach?
Yes. So
Yes.
are there ever times when cursor is a preferred approach? There are some use cases out there where cursors are actually more efficient. So one example is running totals before SQL Server 2012. A cursor will outperform a self-join on, like if you're doing running totals and keeping a running balance, like,
Excluding window functions.
right. So
Excluding
in
window
2012, they added lag and lead, which make calculating the previous row and the previous set of rows, so you can use range, unbounded preceding, and get that all through Windows functions. But that was introduced in 2012. So before 2012, there wasn't really an efficient way to do that. And if you have a self-join where you're calculating the sum of every previous row every time, that doesn't scale, right? So when you add more rows to the table, the performance, or the time it takes goes like this, hockey sticks.
And there are plenty of situations where cursors may not be the absolute best way they can be, that it can be implemented, your solution, but they're not bad. And so
Right.
that's
And-
kind of what this slide is about.
Yeah, and so another case is maintenance. So if you have to call a stored procedure for every row, like for every database, for example, or you need to send an email to every recipient in a list that you pulled from a query, there's not really a way to call another stored procedure as a set, right? Unless you rewrite the target stored procedure. So there are definitely cases like that. And also, I write a lot of maintenance for DDL, and I use cursors for a lot of that stuff. And a lot of times I'll use string aggregate concatenation. So I'll build a string using a query where I just append to the variable, and that's a cursor under the covers. I don't use declare cursor syntax, but it's the same kind of thing. And there's not really, it's the same issue. There's not really a good way to do that as a set, right? So you kind of have to use cursors all the time. It just doesn't always look like you're using cursors. And it's funny you mentioned the while loop, because I wrote a blog post last year or the year before where I called it a fallacy that a while loop wasn't a cursor. A while loop is a cursor, it just doesn't say declare cursor. It's the exact same thing. Any other questions before we go on? Okay, good. Oh, we have one. The slides, this slide you should already be able to download from the past site. It wasn't on the past site? Okay.
We'll upload another
Yeah.
version, but
Yeah.
we've already posted this up there.
Yeah, we'll make sure it's up there. They'll be there. Okay, so default cursors. How many people use cursors in their code regularly, or have plenty of cursors in their code? And so a lot of people will use declare C cursor for, or declare cursor for, and then just dump their query there, and then they'll process their stuff. This is pretty expensive. The defaults in SQL Server are global. Global means that if I'm in a stored procedure and I declare a cursor, if I have a stored procedure that called that, I can access the cursor from outside of that scope, which isn't usually something that we need, right? They are scrollable, which means I can fetch forward, I can fetch previous, I can fetch to an absolute number. They are writable, which means that I can use where current of to update the current row instead of performing an update separately outside of the cursor. And they are dynamic, which means they will respond to changes to the underlying data. So one of the major problems this causes, how many people use SP/MS for each DB? Anybody use that for maintenance tasks? You need to stop using that. I'm absolutely 100% serious. Every once in a while, that stored procedure will skip databases. I've written a blog post, I've written a replacement stored procedure that you can use. It should work almost exactly the same way. There are a couple of bugs in the stored procedure that it fixes, so bad database names that have dashes. There are some things that will break when you use SP/MS for each DB. If you're using that, it's obviously not happening to you, but it's just an extra protection you have in case someone creates a SharePoint database that starts with a number or something. And what happens is, if you have any state changes to any of the databases in your system, the cursor is dynamic. So it could say, oh, well, that row is locked right now because there's a change happening and someone is updating the sys.database's view in memory, right? So it'll just skip the database. It won't tell you. It won't return an error. And the reason for that is that they declared a cursor in that stored procedure with the default options. And it's just dangerous. You can miss rows when you do that. You can also repeat rows, because if it's dynamic, it might actually process the same row again. It's kind of like dirty reads, right? Because it responds to the underlying changes.
So there must be a better way.
There probably is a better way. So in addition to the problems that the default cursors cause, there is also a performance issue. And I will show that here. So I'm going to create a very simple table here. I'm just selecting a name into here from sys.all columns, and I'm just cross-joining to create a whole bunch of rows. I forget how many rows this creates. I think it's 500,000 or something. That should take about a second. Yeah, 500,000 rows. And now I have a very simple cursor. I'm just declaring a variable, declaring my cursor with the default options, for selecting the name from that table, No order by, no where clause, nothing. Very simple query. Open the cursor, fetch into the variable, use my while so that I know that there's another row coming in from the cursor. Increment an integer variable, very simple.
Yep.
Fetch again on the inside of the loop, close and deallocate. How long do you guys think this will take? I'm going to start it and then let someone guess.
10 seconds.
How many? 10 seconds. You're very close. Kevin, do you have any jokes to share? Any limericks?
Oh, I have way too many jokes and limericks.
There, 11
right,
seconds.
11
Very
seconds.
close. Very good. If we had a book, I'd throw it at you. All right. So now, well, throw it softly. You'd be able to catch it. So I'm going to show you a little trick. I'm going to type in a demo. If anybody knows Buck Woody, don't tell him I did this.
Right. It's a major sin for a lot of us.
So I'm going to use two keywords here that change the cursor from global to local, and from read-only and updatable and scrollable to read-only and forward-only. Okay? So I'm adding the keywords local and fast forward. Oh, and that's why you don't type in a demo, because
That's right.
if you're a terrible typist, you make spelling mistakes. Okay, so that's the only change I made. I didn't change anything else. The table hasn't changed. If I run this, how long? 4 seconds. So I just cut my execution time in more than half simply by changing the keywords in that cursor. That's it.
And this was an extremely small data set. You know, if it was a lot wider, a lot more columns, it would have a commensurate impact on the performance of that as well. Yes?
Why do you think that the team chose to make those the defaults?
Why did Microsoft choose that particular set of defaults for cursor behavior? And in fact, that is a question I ask myself frequently when looking at all kinds of different things inside of SQL Server. You know, why did they choose a database size of 2 megabytes by default and a transaction log size of 1 megabyte by default? One grows by 1 megabyte at a time, and the other one grows by 10% at a time. Why? I don't know. Does it make sense? Absolutely not.
I do have a theory. And I think that the reason they chose those as the defaults was to supply all of the functionality you might need. So it's kind of similar. How many people use ORMs to develop code, right? So entity framework, all of those things. So they basically give you the entire factory. You know, they're not giving you a product. They give you the entire factory, and so that no matter what you do, it will work. So with a cursor, if they give you all of the options, if you say fetch previous, it's going to work with the default cursor, instead of making you turn that on if that's functionality you need. Now, I'm the opposite. I think that if you do need that functionality that's actually more expensive, you should have to enable it, right? So that's my way of thinking. They want to be inclusive, so I think when they were developing certain features, they want to reduce the amount of support. So they don't want people calling and saying, why can't I fetch previous on this cursor? And having to look in the documentation and figure out how to turn that option on. They want the options to be on so that it just works out of the box. So I understand the point if that's what it is, but that's my theory.
Another kind of sidebar to that of why do we get the defaults that we do and they just don't make any sense is a lot of the defaults were set. Paul Randall talks about this occasionally on his blog. He was part of the storage engine team for many, many years. And he'll reveal some of these little tidbits every now and then, and he'll say something, paraphrasing, but something like, well, at the time we wrote that default rule back in 1999, that was a pretty aggressive, pretty progressive way to set the default. But what year are we in now? We're actually in a whole different century, right? And so that old default made sense at the time we set it. But it doesn't make sense now.
A really good example of that is page life expectancy. How many people have seen, if page life expectancy is lower than 300, you have a problem. You've seen this advice everywhere, right? Mm-hmm. It's garbage. You need to understand what your page life expectancy usually is. For some data warehouse systems, page life expectancy of 10 is not uncommon, and it's not a problem. So it's really hard to take any certain, there are a lot of defaults that just aren't applicable across the board. And there are other things that I know that Paul and other people in Microsoft have told me, why is this the default number for something? And it was just, someone said, I think it should be this. There wasn't any, there's some of those decisions, there's no logic behind them whatsoever. It was just what someone wrote on the whiteboard that day, and
Right.
that was what stuck.
No PhD mathematician. They're like,
Yeah, they
"I
didn't
think
have David
40 sounds
DeWitt
good."
making calculations for them. Yes?
Was local part of the performance improvement, or is that just?
Yes. So the question was local part of the performance improvement? And yes, it was. So I don't know all of the internal mechanics. I'm not a software engineer, so I'm not sure of everything that's going on there. But I have a blog post right here where I do test against all of the options, and with local on and with local off, and when only changing that, the performance was better. Yes? If you do a cursor on a local temporary table, does it make it global? No. So the data that comes out of the cursor, I've actually never tested that.
I haven't either.
But I think that once you pull the data into memory, you'll be able to access that globally if you do that. I've actually never seen anybody intentionally make a cursor global and use it outside of the scope that it's in. That's a functionality that exists, but I don't know if I've ever seen anybody do it.
Yeah.
I haven't tested that. That should work, but it doesn't make the temp table magically global to ever, you know what I mean? The temporary table doesn't become global. The data that's coming through the cursor and is in memory in the cursor should be visible, but again, it's not something I've tested. Any more? No? Okay. All right, so the next one. I see a lot of people, I spend a lot of time on Stack Overflow, dba.stack exchange. I used to spend a lot of time on the Microsoft Newsgroups, NNTP. And for a long time, I see people writing queries that say where customer ID not in something else. So there are a couple of things that can happen there. One of them is that if the source column is nullable, so if you say customer ID not in, select customer ID from customer feedback, a customer feedback table, maybe that column is nullable, you're going to get really funny results. And that is because you can't compare a null to, you can't say equals null. So what not in does is basically expands that to a bunch of a series of not equal to.
Right.
And you can't say not equal to a null, right? That'll come back unknown, which will come back false, which means when you go back out and say not in all of these false things, that becomes a true and returns all of the rows. So that's something to watch out for there. Then I see a lot of people, they switch from not in and they use left out or join. And then the where clause will say where the right table is, where some value from the right table is null. And that can be a performance issue as well. I've got a quick example of that. I prefer not exists. Not exists is a pattern where you can use, and it will, instead of performing a full join, it still does an anti-semi join, but it has the inner capability, I believe, to short circuit in a way, in some cases. Won't always do that, but it can. And another form that was introduced in 2008 was accept. And there's an important thing to know about accept before you decide to switch to that functionality.
And just as Aaron pulls up the demo to demonstrate this too, it's a common feature of relational databases that they're great at putting sets of data together. Relational, right? I'm going to find the relationship between these two. Relational databases in general, just because of the way they're built, are not good at finding not the existence of a relationship, right? Because the way I find if a relationship doesn't exist is I have to look at all the relationships that do exist and then rule them out based on the other one. So it creates a lot of additional work in certain circumstances when you're trying to find not a value. So it's one of those strange little things that just comes along with the territory.
Okay, so in this demo, I have a very simple table variable that has a single integer column. I'm putting in 2 copies of the value 1 and then a null value. And then I have a second table B that we can assume this represents customers and orders, let's say. So we have a customer that maybe has multiple orders, right? And I'm just going to compare what happens when I use not in versus not exists versus accept. And what happens is the first query returns 0 rows. And that is probably not what you would expect, right? I would expect to see 2 come back from this query, but it does not because it doesn't match that equals null. You can't equal a null. So what happens is everything gets overridden by the comparison, and we end up returning 0 rows. Probably not what you expect, especially if you're writing the query and you don't know that the target column is nullable or that any null values exist, right? That if I didn't put a null value in that table, that problem wouldn't happen. So you have to know the data to know that that's a valid construct to use. Now, when I use not exists, I get both of the rows. So I had two customer IDs that made it into the orders table that didn't exist. So there's some problem in my referential integrity. Doesn't really matter. It's not part of what I'm trying to solve here. But I do get both of those rows. So maybe that's what I intended. Maybe it's not. It's good to know how many times this happened. So you probably want all of the rows. What except does, except returned a single row. Right? So I asked for all of the rows, all of the customer IDs that were in the second table that don't exist in the first table using the except keyword. And what this does is it adds a sort operator. It adds a distinct sort operator. That can be a performance problem, especially if you did want both of those rows. That's a logical problem, but that distinct sort operation can actually add a performance problem too. So especially in cases where you don't have any, maybe it's not possible to have duplicates, but it will still add that sort operator there. So,
according to the ANSI SQL standard, there's this class of clauses that are called set operators. And the most famous set operator of all is union. But there's a couple others that are less commonly known. Intersect, and then minus, or except. Those are synonyms one to the other. And if you've ever worked with unions, you know that you can also say union all. And so it cuts out this step, this intermediate step on a union statement that does that sort at the end. So you can actually specifically say union all, or you could say, what is it, union distinct, I think is
that's the official, but it's not
full
necessary.
official syntax.
It's optional.
But it's implied if you leave it off.
Yeah,
That's
and so just another thing about union and union all, I think every single time I've asked someone on Stack Overflow who was writing a query and they had a union between two queries or multiple, sometimes they have 4 or 5 unions, every time I ask them, are you sure you need union? Do you need to eliminate all of the duplicates from any of those queries? And they're like, no, I don't know what you mean. So a lot of people I find don't know about union all and don't realize that that's probably what they should have been using all along. Mm-hmm. Even if they weren't losing duplicates from using that in that specific case, they might have had other cases where they don't realize they're losing duplicates.
Right.
Union all is a lot faster, yes. And it's precisely because you don't have to do that sort and distinct. Okay, so this is just an illustration of the query plans where we see that the except version is more expensive, and it's exactly because we added this distinct sort operator right here. All right. And now we'll do the opposite, where in versus where exists. So this is a little more straightforward than the not in, because we don't have to really worry about the null. Well, I guess we kind of do still have to worry about the nulls. But it's not something that happens quite as often. I find the not in is one where that pattern exposes itself in a bad way quite often. So we have several different ways where we can find existing data within subsets. So we can use in, we can use exists, we can use apply, we can use a subquery, we can use CTEs and self-join. There are all kinds of things like this. This is another case where, so with not in, I prefer not exists. Exists is definitely the preferred method here if you don't need any rows from the second table. So if you want to know all of the customers that had an order last month and you don't need any of the order details, definitely use where exists instead of a join. The reason is where exists will actually short circuit and stop processing rows for that customer as soon as it finds one order. So you end up doing a lot less I/O. Depending on the distribution of the data. The worst you can do is the same. So there's no reason to use a join if you don't need any columns from the second table.
Right. So when you're using that exist statement, just to reiterate, as soon as it finds any presence of that value, it stops. So it might look at one row and it's done. Whereas if it has the where in, or some of these other constructs, it has to now go and look at all the rest of them just to make sure that, so if you only care about, do I have any of this activity happening, exists is going to be typically a far better way to take better performance there.
Right. Okay, so the next one I'm going to talk about, optimizing for select versus DML. So one of the things that I see people often do is they will take a recommendation from the index tuning advisor or the, what is it, the database engine tuning advisor,
yeah, DBTA.
Or from an execution plan, they'll get a missing index hint that says, hey, you should create this index. There are all kinds of other ways that you can get this information. And what people will do is they'll say, oh, well, I need to make this one query faster, so let's create that index. And now my query is going to be faster. Well, that's great, except you don't know what impact that has on the rest of your workload. You don't know how big that index is going to be, how much disk space it's going to take, how it will affect your maintenance. There are all kinds of trickle-down effects that when you're tuning one query and you're only looking at that query in isolation, you don't know about, you don't realize. So one of the things I try to guide people in doing is making sure that they have a full and representative workload that they can test against. If you're going to create an index, you better have a good feeling for what that will do to the rest of the workload. You definitely don't want to add an index to make the CEO's report that runs once a month faster if it's going to slow down your ETL workload by 20% all month, right? So a better thing to do there is cache the data they need for the report right before, the night before they run it, or you can build the index the night before they run it and drop the index afterward. So you pay for some of that maintenance, but at least you're not paying for it all month.
You're basically looking at a situation where there's a cost to achieve that benefit. So the benefit of adding indexes is our selects can be faster because we're able to find the specific rows that we need much more quickly. The cost comes on the DML side of the house, the data manipulation side, when we do inserts, updates, deletes, merges. Any of those statements are going to have the pointers updated in all those indexes. So if you have the same table that is used primarily for selects, adding indexes will generally be a good thing. But if that table is also used for a large number of inserts and deletes and things like that, then it's going to take longer because we've got to update all those indexes. And that same table, if it has 5 indexes, will take X amount of time. But if it has 40 indexes, it could wind up taking a multiple of that because we now have a whole lot more indexes that we have to keep up to date with all these DML, new records coming in, old ones being taken out, and so forth.
Okay.
If I could tell a little story too, that's kind of funny. One of the first ways that many of us learn how to write SQL statements is we start with SQL. With select. I'm getting all my acronyms messed up. So we start with select statements, and then we move on to more complex things. We start writing stored procedures. Maybe we're starting to do inserts and updates and deletes. And at least in my case, when I'm going to write a delete statement, what I do is I'll first write a select statement that I know proves definitively that I get the records that I want to delete and no other records. I once asked a group in a query tuning session, well, how do you do that? And one person said, oh, I just use rollback. I thought, all right then, let's see how that works out. But one of the things that really surprised me was the first time I went and took a look at, the first time I'm learning how to write these insert statements, for example. So I got a select statement that affected just the data that I knew I needed it to affect. And so now I'm going to do an insert with a select statement to move it into another table. And I was really, really shocked by the fact that it went from a query execution plan that was small, just a couple lines, and then when I did it as a select, but then when I did it as an insert, it was huge. It was enormous. Not really doing much different, though, in terms of the data that it's touching. What kind of things do you think might have caused that insert? Or the same thing can happen with an update or a delete. Why would a DML operation that touches the same 15 rows on a select be small and compact, but on a DML operation is huge? I hear indexes, I hear locking. The main thing that will cause you enormous amounts of complexity are your keys, your constraints, right? So if you have foreign keys that say you can't insert a sales detail record without a sales header record, well, how do I know that a sales header record exists for it? It's basically a select on the sales header record, right? And how do I know that the customer ID is a valid customer ID? Well, I basically have to do a select statement against the customer. And the product key, well, that's also a select statement. And so each of those actually gets added into the execution plan for the DML operation, where it doesn't appear at all for the select operation. There's a couple other, that's not the short list. So if you're thinking, well, is that the only thing? Well, there are other things too. For example, if there are triggers on the table. So if it has an insert or an update or a delete trigger, that gets built into the execution plan as well. So I'm not telling you not to use that approach of first writing it as a select and then coming back and creating a DML version of that. Definitely do that. But I was really kind of blown away by how much more complex it was when I first went to the delete statements and the updates. So just be aware that that's going to take into account all of your triggers, all of your foreign keys, if you have check constraints and different things like that. That will all show up in the execution plan as well.
Do you mind if I go on a little sidebar as well?
Yeah, let's take it on the sidebar there.
So Kevin mentioned triggers and rollback. And one of the things I see a lot of people do is write a trigger, an after trigger, that checks some business rules, maybe checks some data, does some things, and then might perform a rollback. So this is kind of like washing your car before you drive through a mud puddle. What you can do and what you should investigate, in some cases, an instead of trigger is going to be a much better option if you know you have a likelihood that you're going to roll back. So what an instead of trigger will do is it will allow you to check the business rules before it writes to the table, before it writes to the log, before it waits for the acknowledge, before it does all the rollback. It says, if my business rules match, that's the only time when you want to do the insert, instead of an after trigger, which always does the insert and then might roll back, right? So this first dawned on me when they first introduced DDL triggers. And policy-based management works this way too. If I define a policy in policy-based management where I have a naming constraint on the name of the index, say I want every index to start with IX underscore, and if it doesn't start with IX underscore, don't create it. Policy-based management uses an after DDL trigger. There's no such thing as an instead of DDL trigger. Mm-hmm. And what happens is, if you have let's say you have an 8 billion row table and it takes 12 hours to create the index, it will go ahead and create the index, and then it'll say, hey, wait a minute, your name, this name is no good, let's roll back. Now, the rollback can take 12 hours. If the initial create index was multi-threaded, it could take a lot longer because the rollback will be single-threaded.
Yeah.
So that's something to watch out for. But it's parallel to the after trigger. The instead of trigger is a little more work to write because you have to repeat the insert statement, but it can save you a ton of execution time by not bothering to insert a row just to roll it back. Right? You just don't insert the row at all. Saves a lot of work, saves a lot of I/O. So, yep. Kevin, you want to talk about
so let's talk a little bit more about another thing that we see happening very, very frequently. We see a situation in which we don't even realize it, but the way that we have written a particular set of SQL code is going to just automatically have recompiles. Now, what is preferably going to happen is SQL Server is going to take a look at the batch that you've submitted. It's going to take a look in the plan cache to see if it already has something in the cache that it can reuse. If it can reuse it, it will. It might result in parameter sniffing. You heard that term earlier. It might not. But hopefully it's going to find a good plan in cache. It'll use that one and doesn't have to go through the whole process of compiling it. If it doesn't find it in the cache, it has to load the metadata. It creates a query hash called a query fingerprint. And then it compiles that and loads it into the up into the cache so that it can execute it. That's what happens normally. However, and here are all my animations. I talked right past my animations. So normally it will get loaded, right? Let's walk through this quickly. Sometimes, though, it won't find it, so it's got to go through that whole process of building the execution plan, right? It's got to go through the parsing and the binding phase, the compiling and optimization, and then it gets loaded in. The problem that we have is that there are certain things that we can do in the way we write code, and many times we don't even realize that SQL Server is going to do this by default, where SQL Server says, okay, based on X number of reasons, there's certain kinds of reasons at play here, I'm going to have to recompile this execution plan, even though there's a perfectly good one up in the cache. So some of the different causes that we have are because we want it to, right? So we might tell a SQL Server when we create a stored procedure, for example, that we want this to recompile. So every time it's invoked, we create it with the recompile option, and whenever it gets invoked, it will build a new plan. It's just part of the nature of that particular stored procedure or whatever it might be.
Can I ask a question
Yes.
of the crowd? Does anybody use create procedure with recompile? Anybody add that option to the procedure?
Okay.
Sometimes. If you're on modern versions of SQL Server, you shouldn't do that anymore. So if you're trying to optimize certain plans and make sure that they recompile every time, you should do that at the statement level. When you do it at the procedure level, you're invalidating every single statement in the procedure. And maybe it's just a select and it ends up being roughly the same. Highly recommend using option recompile on the statement, at the statement level instead of at the procedure level. If you're still in 2000, or maybe 2005 too.
Yes.
Yeah, but if you're on anything more modern than that, I definitely recommend using option recompile on the statement level.
There are a couple other reasons that you might cause something to recompile intentionally. It's the unintentional stuff that we worry about. So, it gets aged out of cache. That's all right. That's the natural and normal behaviors of SQL Server. I'm going to tell you a little bit more about a couple of these, such as the way we interleave our DDL and our DML statements, okay? And then there's also some underlying changes in the SQL Server schema or the SQL Server configuration settings that can cause recompiles to happen when we don't intend for that to be the case. For example, SP configure. Now, would that apply to all SP configure settings?
No.
Okay.
So
Tell me about that.
So there is a myth out there that if you run SP configure or the reconfigure option, that all of your query plans will go away. It'll clear the plan cache. So that is true for certain server configuration options, but not all of them. So if you change max server memory, that will flush the plan cache. If you change XP command shell from on to off or off to on, that's not going to clear the plan cache. If you do a search for myth SP configure cache, there's a blog post someone put out there where they actually list the specific server options that will cause it. This is something I would never do, but they went through every single option and tested to see if the plan cache was. That's pretty involved testing because there are a lot of options.
And when Aaron says there's something he would never do, in this case I don't actually believe him because I've seen him do some really detailed tests. I hope you take advantage of those links he put in there because all of these statements that he is making are very thoroughly backed up by testing evidence. So very good reads for you. So let's talk about these in a little bit more detail. The most common one I see is interleaving DDL and DML. This is also kind of interestingly something that each new version of the optimizer gets better at detecting than the older version. So like in SQL Server 2000, if you had a batch of SQL code, a stored procedure in which one of the first things you did is you created a temporary table. Well, create, alter, and drop are the DDL statements. Okay, so the first thing we do is we say create test DML. And then we have an insert statement. We insert some values into test DML. And then we come back and we say, let's alter that and add another column because we're going to make another run through and add some more values in there. So we alter table, add column. And then we say update that table. So now we've had DDL, and then we have DML to insert, and then we have another DDL to alter the table, and then we have another update, and then we have, and we keep making changes to this table, and each time we make a change to that, what SQL Server does upon execution is it takes a look and says, okay, I'm going to process this code. I don't know if any of the statistics I had for that are correct. I don't know if any of the underlying scaffolding for that are correct. So I'm going to recompile just to make sure that the plan is right. And there's this horrible thing in SQL Server, some people love it, but there's this horrible thing in there called deferred name resolution, right? And so this can get a lot of people in trouble because what SQL Server allows you to do is it allows you to do all kinds of stuff against objects that don't yet exist. Because the assumption, it doesn't fail at the runtime or the compile time for the stored procedure, it'll fail at execution time because, hey, maybe some other calling procedure created that.
Or,
But it's not there
or
yet.
they assume that you're writing the stored procedure now, but you haven't created the objects yet.
Right.
And it's terribly inconsistent, too. You can reference a table that doesn't exist, but you can't reference a column that doesn't exist in a table that does. You get an error message at compile time instead of runtime. So it's not even consistent the way that they implemented it.
So in SQL Server 2000, 2005, that whole thing has to recompile every time it's invoked. If it sees interleaving DDL and DML, the whole thing. 2008, it'll pick up where it left off on the last recompile. So it'll get a little further, and then the next time it recompiles, it'll get a little further on, and so forth. So it does get better with each new version, but it's kind of bad when you start. I had a situation where a friend had called me in to look at a big system that his company had. And by the way, if you ever are thinking about buying a packaged application in which the vendor tells you, you are our biggest customer ever, we're so happy to have you as a customer. It just run and tear, you know, it's not going to run well for you guys because it's designed against a much smaller test space. And so they actually had a design for the system in which anytime they did reports, they would create a temporary table. Then they would load that with data, and then they would change the table around and manipulate it in that table, and then they'd load more and update. And it just took an enormous amount of time because of a huge number of recompiles. There's a couple kinds of solutions you can implement in a situation like this. What might be the first thing you would think about trying? Sorry? Split it out. Yes, very good. So we could use subroutines, right? So maybe we could have different stored procedures. And so rather than specific statements here, we might have a stored procedure that does the insert, a stored procedure that does the update, right? And so only in the very first statement do we have the create table statement, right? And that's the only thing in there before we start calling other stored procedures. You might do something, so subroutines or something like that. You might try to, compress all of your DDL to the very, if you know you're going to change it and add columns, why not just create it to begin with all the columns that you need so that you don't have to worry about the interleaving. It's the interleaving that makes the problem. So if you can force all your DDL to the top, all the DML to the bottom, we don't have as much interleaving. So that also can cure it. In our case, when we just analyzed what we were doing, we realized that we use these tables all the time. Why not make them permanent tables? Why not put indexes on them? Why not make it a heck of a lot faster? Woo! So just takes a little bit of thought, a little bit of planning, and it will perform better for you. So speaking about trying to do too much at one time within, let's talk about this one.
All right, so this is a pattern I see quite a bit as well, the kitchen sink stored procedure. This is the stored procedure that takes 15 or 50 or 800 optional parameters and then builds a ginormous where clause with a bunch of ors and says if this parameter, if the column is equal to the parameter or the parameter is null, and then or if this, or and if this column is equal to this parameter or that parameter is null, and it goes on and on and on and on and on. So the problem with this kind of statement is it is terrible for optimization. So unless you're going to recompile it every single time, which as that statement gets more complex is more costly, you don't want to pay that recompile cost every time. What happens is you will, depending on what the first parameter is called, the first time that stored procedure is invoked, it will compile a plan for that parameter. So if the first time you call it, you say, I'm going to pass in the last name and the first name, and I'm going to ignore all the rest of the parameters, you're going to get a plan that is hopefully optimized for searching on last name and first name. You will also get a plan that has estimates that are based on what the values of those parameters are, and that's a slightly different problem. I'll talk about that as well. This isn't the way we want to do things, because the next time someone calls that stored procedure, they might be looking for a salary greater than or equal to 30,000, and I'm trying to think of another property of an employee. I don't know.
Hire date, perhaps, or something
yeah,
like that?
hire date is greater than the last 5 years ago, something like that. Now, SQL Server is not really going to know that there's anything different, right? It sees that different parameters were passed, but it sees that all parameters were passed. All the parameters are part of the statement. Some of them are null now instead. So it says, okay, well, I have all these same parameters, so I'm going to use the same plan, and now that plan is not going to work so well because it's going to use an index potentially that's geared for last name, first name. Or it might have used a clustered index scan for the first one because there was no satisfying index. And now for the second query, you could have had an index on salary that could have been used, but it's going to be ignored. So there are all kinds of things that can go wrong there. What I typically do for cases like this, if I get more than 2 or 3 of these optional parameters, I change it to dynamic SQL right away. So dynamic SQL is kind of a pain because it's red, right? So well, it'll be black probably on this screen, I'm not sure. And it makes it a little harder to read. So you don't get IntelliSense. There are a bunch of things that you lose when you convert to dynamic SQL. A lot of people think that there are a ton of things that you lose performance-wise. And they think, oh, well, it's dynamic SQL, so it won't be cached. Or it's dynamic SQL, so it won't parameterize. Or there are all kinds of things that people assume about how dynamic SQL is bad. Dynamic SQL is the same as any ad hoc SQL. It's going to compile, it's going to cache the same way, it's going to be reused the same way as long as the text is identical every time. So there's no problem there. What I do recommend if you're using dynamic SQL now, or if you're going to change your kitchen sink stored procedure to use dynamic SQL, enable the optimize for ad hoc workloads setting. Yes. What this does is prevents plan cache bloat. So one of the other objections to dynamic SQL is that sometimes you make these great big dynamic SQL strings, and you have a massive plan that's associated with that. You put it in the plan cache, and now it's taking up a bunch of plan cache, right? Space in the plan cache. Now, if you have a different dynamic SQL string for every single combination of parameters, that's going to take up a ton of space in your plan cache. You might use up all your plan cache on this one kitchen sink procedure if it's called often enough. So what Optimize for Ad Hoc Workloads does is it will cache a stub for every version of this, every combination of parameters that you pass. It will store a plan for that, but it'll only store a stub. It stores like a fingerprint, basically, you called it earlier. Mm-hmm. It won't store the actual plan in the plan cache until you've called that same text the second time.
2 times,
so with the same set of parameters. So that's a good way to offset a lot of that.
Some people like that so much that they encourage you to use that by default as a system setting. I wouldn't go that far, but for most OLTP applications, it can be pretty useful. And a lot of BI applications that are very read heavy, you're churning a lot of, so it can be useful in many different situations. I just don't go as far as saying it's useful all the time, every time.
Right. This is definitely a pattern where it's useful. So if you look at this is the pattern I was talking about. We've got this kitchen sink stored procedure, takes all these different parameters, there could be 20 more. And you see the series of where clauses down here where I say customer ID is equal to coalesce the parameter value, and then if the parameter was null, it's going to say customer ID is equal to the customer ID column. And we do that down the line. Now, there's a slight difference you have to do here if the column is nullable. So for example, ship date is nullable in the sales order header table, sales order header enlarged. And so you can't do that here because you can't say and order date is equal to null. Equals null in SQL Server doesn't work, it returns false. So if you don't pass the parameter, that means you don't care if the ship date is null or not. But what's actually going to happen is you're going to eliminate any rows. Well, this always makes me backwards. You're going to eliminate any rows where the ship date has a value. Yeah,
Either way,
it's going to be wrong. So you either have to write all your clauses this way, where you mention the column and the parameter 3 times, and use is null against the parameter, or you have to do that at least in all the columns that are null. And that means you have to pay attention if the table changes these clauses that use coalesce, which is the pattern I see. Well, actually, I see is null more. In this case, those are identical. But so if any of those change, the nullability of any of those columns change, you have to pay attention to that as well. And like I said, this store procedure is going to create one plan for this, and it's going to reuse that same plan no matter which parameters are passed later.
Exactly. So you get a big generalized plan, just like the old expression, jack of all trades and master of none. Well, we want to write a query that's going to be a master of the data set that it needs to bring back for us. But right. This is just generalized for whatever might be thrown at it.
So the way that I usually attack this problem is I create the beginnings of a query. So you just need to select the same columns, obviously. And then, so that I don't have to do any conditionals like, well, is this the first parameter that wasn't null? I say where 1 equals 1, which means it will automatically include all the rows. And then I add an and for every parameter that exists. Now, what I see a lot of people do, and I'll show an example of this further down, is they'll build the string, the entire string dynamically. So they'll say, well, I'll show that in a second. The way that I like to do it is to use SPExecute SQL. And this way, I can build the dynamic SQL string by saying if the customer ID is not null, then add a where clause that references that customer ID. Right? So I just say and customer ID is equal to @customer ID. Same thing with order date, same thing with ship date. So no matter which of those parameters are included or are not null, they get added to the where clause. Then I can pass all of the parameters into SPExecute SQL. They don't all have to exist in the query. This is a nice thing that a lot of people don't realize about SPExecute SQL. You can mention parameters in that list that weren't actually part of the SQL text that's passed in as the first argument. So that makes it very easy. You don't have to do all of this. I've seen people do this, where they do a bunch of conditional creation of the parameters clause and the list of parameters that are passed to SPExecute SQL. I've seen this like 64 branch nested if statement that called SPExecute SQL 64 different times with the same SQL every time, but different sets of parameters in the other two parameters to the procedure. Yep. So what you don't want to do, and I call this one kitchen sink bad dynamic SQL. Everything at the beginning is the same, but then when we come down here, people build these strings where they're not parameterizing any of these values.
Just concatenation,
they're
right?
just concatenating everything into the string, which means when you have an int, you have to convert to a string first. When you have a date, you have to convert to a string. When you have a string, you have to worry about single quotes. Like there are all kinds of pitfalls and dangers here. You also lose a lot of the values of parameterization. You also open yourself up to SQL injection, right? So if you're not parameterizing the input that's coming in here, people could append drop table Bobby tables right here, and then you would lose Bobby tables.
And if you've ever spent any amount of time counting your single quote marks, using that the SPExecute SQL will help with that. You don't have to count those quote marks.
I've written, I think I've had a couple of answers on Stack Overflow where I've written a dynamic SQL maintenance answer for someone who was trying to change foreign keys or something, but it had to be nested. Mm-hmm. And I've had, I can't remember if it was 18 or 24 single quotes in a row, mm-hmm. because it was nested 4 times, and you had to, every time you escape a single quote, you have to double, mm-hmm. so you go 1, 2, 4, 8, and just to get that single quote ending in the final eventual statement. So building dynamic SQL that way is a mess. You want to parameterize everything that can be parameterized. So if you can't parameterize table name or column name, but you can parameterize anything you're comparing to a value. Mm-hmm. And you should do that as often as possible. And that happens to be my next slide. SPExecute SQL versus exec. On some versions of SQL Server, older versions mostly, SPExecute SQL will promote better plan reuse. But the more important thing is what I was just talking about, encouraging using strong type parameters instead of appending all these strings. Right? So SPExecute SQL lets you do that and use parameters for all of these things, and it will let the optimizer use those parameter values when it's figuring out what plan you should have. Now, another thing about the dynamic SQL solution, a question I get a lot when I post answers like that, or I give customers new code that works that way, how do I defeat parameter sniffing? Does that take care of that? And it doesn't. Parameter sniffing can still happen even if you do have only the parameters that you use in those dynamic SQL statements, because you can build the same customer ID. Let's say customer ID was passed in. So you build the first time you run the query, you build it with the customer ID and you pass in 52. And let's say it's the sales order, the sales table or something. And so customer ID was 52. He had 5 orders. And query plan is built for that. The next time you call the procedure, you build the same dynamic SQL statement, you pass in customer ID 65. Customer ID 65 had 10,000 orders. He's a very happy customer. So what is going to happen is it's going to use the query plan that only had to read one page to go find all 600 pages or whatever it is, you're going to get a different plan there. So in the dynamic SQL, you can actually put option recompile in the SQL itself, and that will make sure that the parameters are reevaluated every time the query is run.
One other footnote on this as well. This is another area where versions make a big difference. So the newer the version you are, the better the difference you'll see between SP execute SQL and exec. So if you're on, say, SQL Server 2005, and you have an exec statement where you say exec and maybe select statement, and you want it to execute it. Just a difference of a couple spaces might cause 2005 to actually not find that plan in the cache. It's the same operators, the same predicates and things like that. It's just that we've changed the text and the way it gets loaded into the cache, and so now it won't find it. Whereas if you're passing in the same parameters every time with SP execute SQL, it will always find that no matter what version you're at. So it can be helpful in other ways as well. But that one is pretty much conquered by more recent versions of SQL Server's Query Optimizer. It's much smarter for that.
Okay, so the next demo I have is about comma delimited parameters. So this goes back quite a ways. People have been splitting strings for a long time, and then it kind of disappeared for a while, and then JSON came into existence. So now people use, how do you pronounce it, JSON or JSON?
I say JSON personally, but
okay.
That's just
so
me.
This is just this big pile of strings that are separated by commas, and now people want to write stored procedures that accept this as a parameter, and they don't quite know how to do it. What do you do? How do you process this list? And I've seen so many bad functions that will loop through a character at a time and say, well, let's build this string back up together until we find a comma, and then we'll start over, and we'll build another one until we find a comma, and oof, just so bad. String splitting is expensive, even CLR. So Atom Mechanic has written a fantastic CLR splitter. I've used it in the past when you can implement CLR. I realize not everybody can. It's not always an option that you have. When you can, if you need to do string splitting, you definitely want to do it in CLR. But even in CLR, it's expensive. It can be a lot of overhead when you're trying to evaluate, especially larger strings. The larger the string, the worse it gets. What I like to do is use table value parameters. How many people are on 2008 or better? Almost
Yay.
Everybody? Okay.
Great.
Anybody not on 2008 yet and not going to be there anytime soon?
Okay.
Okay, so just about everybody will be able to use table value parameters soon. Okay, that's good. Okay, so the first example I have here that's called find orders using JSON broken. I've never said that out loud in my life, actually. That's why I didn't know how to pronounce it. I just assumed it was like our coworker, Jason. So we have this stored procedure.
It was the axe murderer from all those Friday the 13th movies.
I forgot my hockey
I don't
hockey
like to
mask.
say that.
I am wearing a Bruins shirt, though. I am wearing a hockey shirt, but not a hockey mask. All right, so this stored procedure takes a list of comma-separated values and attempts to find all of the orders that are in that list. This is a common approach that I see people try the first time. It doesn't go very far because it fails. Right? So what happens here is people think that, well, if I pass this string, it's just going to make that a list of integers. No, that it's trying to find a value with all of this entire value. It's not looking at each value individually. It's looking for the whole string. It's never going to find that in the sales order ID column, in one tuple. That's what I like to. All right. So that's not going to work. I'm not even going to run it because we all know it's going to break. So here is a split function that I wrote that uses XML. You don't need to really look at what this is. This is just a split function. They're all pretty much the same. They're all going to work pretty much the same. One's not going to be super fast compared to another. So I'm not trying to get you to look at the code. The code isn't what's important. It's just a function that splits the string using XML. And then we have this thing where I say find orders using JSON fixed kind of. And I'll get into why I say fixed kind of in a second. So what this does is it takes the list in, and then it builds a set using that table valued function and says where it's in that set. And then the final one, we're going to create a type called dbo.integers. So this is a generic table type. It's an alias type that just allows you to store a list of numbers. So same idea, instead of a comma-separated list, it's actually going to store a set. Now, what they added in C# is the ability to pass a parameter of this type from C# to your store procedure, or VB, or whatever your language of choice is. I think just about every modern language supports this in some way. It might be called something different depending on the language, but it's there. So what that allows you to do is when you have a data table in C# or some kind of collection, you can just say this parameter is equal to the data table, and the SQL DB type is type.structured. And that allows you to take your data table and pass it right from C# into a store procedure. And that's a table. Much more powerful than any of the splitting techniques you're ever going to find, right? The other thing about that is oh my gosh, I completely lost what I was going to say.
We're running late, so let's move on.
All right, all right. Okay, so I'm going to create all of these, and they already exist, of course. And I think I have this right here. So basically what happens is, now it's a small data set, so the timings here aren't very representative of what's really going to happen. But if we look at the execution plan, this is my split function. I don't even have to zoom in here. You can see this is a pretty complex execution plan, right?
Just to split those
Just to split,
commas
just to
out, yeah.
split those all those comma-separated values up, so I can actually compare them to my actual table. There's my TVP. Oops. I've got a clustered index scan on the table type and a clustered index seek on the table. This is much more efficient.
Much.
That's all I have about TVPs,
Very good.
except for that one thing that I forgot.
And you'll see from a lot of bloggers, a lot of writers, they will be talking about TVPs is a great way to improve your performance anytime you're passing those multi-row data sets around like that. It's a great way to speed things up. Now, one of the last things that we want to talk about, we're just about to wrap up, so bear with us, and that is implicit conversions. This is kind of the ninja stealth killer of performance in a lot of applications. There's just so many situations in which, because we're not really keeping track very closely of the underlying schema, the design of the tables and views and things like that that are being used, we lose track of the fact that SQL Server has this hierarchy of schemas and how compatible they are one with the other. And so when we don't keep track of that, there are lots and lots of times in which we subject SQL Server to trying to figure it out yourself. So when we are very explicit, just like we were saying with the kitchen sink stored procedure, when you can be as specific as possible, SQL Server is able to make much better optimized choices for the performance. But when you leave SQL Server to guess for itself, it's not really sure exactly how you wanted to do this, so let me just figure it out on my own and I'll take my best guess that I can. And so a couple things I want to point out. For example, there are some really useful resources that we mentioned here in the slide deck. Let's see if I can pull those up here. So, oops, wrong one. Preview.
Yeah.
So there's a really nice chart that you can download, a very high resolution graphic, and I'm not sure how to magnify on this. There we go. So you can see, for example, what is a binary compatible with? Well, is it compatible with a var binary or not? Is a small date time compatible with a string passed in? Sometimes, some of these will work automatically, but many, many times, and in a surprising way that you think it might not work, it is actually going to implicitly perform a conversion operation behind the scenes, which means that it's going to lead to a situation where we're going to kind of be leaking out CPU cycles as it does all of these different kinds of conversions. Now, another thing I wanted to point out is a couple utilities you can get. And again, we have the URLs for these utilities you can download. So the first one that's up there is by a person named Ian Stirk from the UK. He's actually got a book out by Manning Press that I recommend. It's a good one about DMVs. And he has this little utility that you can download that will actually look at a database and it will tell you, let's say, for example, we have employee name throughout this database. It'll tell you all the occurrences of employee name, and it shows you, well, this is an in varchar 50, and over here it's a varchar 25. So you can tell quickly, kind of from a top-down view, whether we've built our database system with incompatible data types throughout. So that's the first little utility there.
You know, it would be an interesting change to that stored procedure, or addition to that stored procedure, or that code, is also identifying all the parameters to stored procedures that reference the same column, or have the same name, as long as you follow the naming convention, and also finding all of the plans in the cache that reference those, and potentially have a different data type.
And that's in the metadata. So if someone here wants to go and write that blog post, we're looking forward to promoting it in the future. So you can look up all the different parameters that the stored procedures accept, and you can see whether they're compatible or not, and data type wise. One thing that also to show you in terms of, let's just go with a quick set of examples here.
I think it's this one right here.
Right here.
Yeah.
All right. So if we look at two situations, and I'll just flip over to the text very briefly here. Whoops. So
You might want to zoom in a bit.
yeah, let's zoom in a little bit on this so you can see this. We've got two very basic, this is example content here. We've got two very simple SQL statements in which, in one case, we're doing a select against the person.person table. And we're going to just look for folks with the last name of Duffy, right? Well, actually, the last name is an in varchar, which is not automatically converted with varchars. It's not flawless or seamless. It takes a little bit of implicit or explicit conversions. So if we flip over and look at those, the behavior of that, there's not really a measurable difference here in the amount of reads and duration CPU, but anything bigger than this kind of hello world sort of application, you'll actually see a difference in the CPU and the duration for that. And then when we look down here at the execution plan, unzoom.
Oh, yeah, so,
This is a Macintosh.
yeah,
so I just don't know
I brought
what-
the fruit, I'm sorry.
I don't know what the heck I'm doing on this thing, right? So we look at this version here, we can see that we have, this sort of normal behavior. And if we come down and take a look,
The top one is bad. Next one down. Yeah.
and we take a look at the pop-up, notice on the farther left side, it says right there in your execution plan, convert implicit.
Now, if you don't look at the tooltip, you would never notice this,
You'd never see it.
right? So it's something you kind of have to dig for. So you have to know when you're writing your queries, you want to be very well aware when you set a parameter, you create a parameter for your stored procedure or you declare a parameter for your dynamic SQL, that it matches the right type in the base table. You always want to make sure that's there because you're not always going to see this. And you might not always, it might not always be obvious when you have a poor performing plan that that's the reason. Because that's buried in the tooltip, buried in the properties panel of Management Studio.
So you won't see it easily unless you're aware of it and know to look for it. Now, this is referenced in the last slide that we were just on, but this is by Jonathan Cahias, a friend of ours who works at SQL Skills. And this, I'm not trying to show you everything about this particular query, but you can get it from his kind of utility, a set of utility scripts that he has. But notice that what we're doing here in this particular query is we're actually taking a look at everything that's in the plan cache that's currently active and alive in the cache, and we're looking for anything that has that convert implicit operation happening. So I've gone in and talked to friends, I've got some poor performance. What do you think might be happening? And let's take a look and see if you have convert implicit happening. And it's everywhere because the developers didn't really do much data type checking at all. They just relied on SQL Server to figure it out and fix it for them. And it will fix it for you. It's just that it's going to cost you to get it fixed. Okay? It takes a lot of CPU for it to figure out.
I was hoping that we would actually have one in here, but we don't.
Yeah, we haven't run a real workload in here or anything like that. All right, so let's wrap up, I think.
Yeah, sounds good.
I think we have one more bonus, though. Let's talk about that. All right, so I'm not sure that we have time to do demos on this one, but did we have that in the demos as well?
No.
Okay.
No.
So one thing I do want to, I kind of want to myth bust a little bit, and we're running short on time, so we're not going to take a lot of time for this, but you will hear people say, or in blog posts, they'll say things like, well, you should really use a table variable for this, because table variables are loaded into memory, and they're not kind of materialized on the I/O subsystem. But the fact is that temp tables and table variables are both materialized in tempdb. That's all it boils down to. And in fact, table variables have another big disadvantage, which is they do not have statistics. You can create a table variable with a primary key, and so I guess at that point it will collect that only on that primary key. But a temporary table is basically just a regular SQL Server table. So it will do things like auto-collecting statistics on frequently used columns, right? So there's all this scaffolding behind the scenes for temporary tables, either with a pound or 2 pound signs, that'll make them perform better if they're generally storing the same information compared to a table variable.
Yeah. There's one addition in SQL Server 2014. You can now declare secondary indexes on a table variable in the declare table statement. However, you do get the benefit of the indexes, but you don't get benefit of stats. There are no statistics for those indexes either. So.
The big benefit that you might get with a table variable is in locking. So it does have a little bit lower overhead in terms of locking. But I really hope you're not doing a bunch of transactional processing on a table variable, because you're probably using it wrong in a case like that. You should really have a real table once you're doing that kind of manipulation.
One place where you can use a table variable to your advantage is in a trigger. So if you have a trigger that will potentially roll back, you can keep data in the table variable and it'll survive the rollback.
Right. One of the things that the optimizer does do with a table variable is it pretty much always assumes that it only has one record in there. And so what if it has 20,000 records in there? You can be pretty sure you're not going to get a great plan out of that.
This is another case where your estimates can be off from your actuals because it's basing that on data it just doesn't have.
Yeah, it just doesn't have enough information to give you a good plan. A related one to that, in this little bonus slide here, is user-defined functions. I know some consultants who actually make a living just kind of rewriting user-defined functions, and suddenly performance on this particular system works so much better.
Yeah. They didn't change anything. They just moved the function to inline.
Yeah. What happens is, now again, not always. There are lots of exceptions to the rule, but generally speaking, and if we weren't paying a lot of attention, or if we were just doing it kind of with everything set to default, UDFs are probably going to have to execute for every row returned by the result set. So if you have a UDF reference in a select statement that's going to pull back 30,000 rows or 2 million rows, you might be executing that UDF 30,000 or 2 million times. So if we can change that into an inline function, things are suddenly better. So be very cautious with UDFs. I'm not saying don't use them, because there are certainly places where they are good to use. But if you are using them, make sure that they're not being invoked for every row returned in the result set. All right? So that's a little bonus. That's number 11 out of the top 10. All right, so we're a little bit over, just a minute or two over on our time. We do want to take some questions, though, so if you'd like to ask any questions, we're right here for you. Any questions? Yes?
When you're talking about application setting and turning it into dynamic SQL, how would you compare that versus that if we're using that as a controller to call separate procedures that were specialized or that set of parameters?
So the question is, how would you compare using all of that the nested conditional logic basically to build a SQL statement versus creating a store procedure for each one? And I would just say maintenance. If you have 64 parameters, do you want 64 times, or it would be 64 factorial stored procedures, right?
Stored procedures,
because
yeah.
if all of the, if only one parameter can be specified, then maybe that's okay. If any combination can be specified, that's a nightmare.
Yeah.
Right?
Yeah.
So.
Mm-hmm. And another thing that we've seen too, you'll see like a stored procedure that is processing these parameters, and you'll see also all kinds of conditionals and case statements. So you've got conditionals up here in the select list rather than down at the bottom in the where clause, and so that can further complicate things as well. So again, the more specialized you can make it, the better the chances are that the optimizer will be able to choose a really, really good plan for that. Yes, sir, did you have a question? Okay, just
hanging out.
stretching your legs. All right. Any other question? Okay, folks, thank you so
Yeah,
much for
thank
your
you.
time. Really appreciate